This is 3.1 characteristics of functions. So on the previous pages in your packet, you have a lot of vocabulary. This vocabulary you need to run through, you need to memorize. There is a quizzes over all of this vocabulary to help you guys know exactly what's being asked of you throughout this unit. So a function passes the vertical line test, which means that the x values do not repeat. If it's not a function, it does not pass the vertical line because those x values repeat. So for example, on this one, we have a vertical line right here, which means that this ordered pair is like 2, 2, and this one is 2, -2, which shows that your x values repeat because we have two x values that are a 2. X-intercept and y-intercept are nothing new to us. X-intercept is where your y value is 0. Y-intercept is where your x value is 0. Domain and range, again, nothing new to us. Just remember, domain is your x values, range is your y values. On the second page of these notes, your maximum and your minimum is written as an ordered pair. And there's two different types of maximums. There is a absolute maximum and a relative maximum. So an absolute maximum is like if you're talking to a friend, you say something is the absolute best. It is the highest point. It's the absolute maximum on your graph or the absolute minimum. Those relative maximums are another high point that is not the highest point. And they're always about like a turn in your graph. So minimum, same thing. With a relative minimum, it's another low point, but it's not the lowest point. So interval of increase, decrease, and constant. So when your graph is going up to the right, we talk about an interval of increase. When you write your interval of increase, decrease, and constant, you are always referring to the x values. And that will be important through this whole thing. So decreasing is going down from left to right, and constant is staying the same. So it's a flat line moving from left to right. End behavior talks about what's happening at the ends of your graph. So it's as it's going on towards positive or negative infinity, depending on the side of the graph you're looking at. So these are the characteristics we're going to be doing throughout this unit, and 3.1 is just the beginning of it. So when we have this interval of increase, decrease, and constant, I like to highlight on my graph, and that way I have everything I need to know. So again, we read a graph like you read the lines of a book from left to right. So starting at the left side of my graph, I notice it's going down. And then it starts to increase. And then it decreases again. And last but not least, it ends with an increase. And I also like to draw my arrows in that same highlighter just so that way everything is visible. So now when we're talking about the interval of increase, we are talking about the x values. So we're saying, what is the x value when it begins increasing, and what is the x value when it stops increasing? So this is our beginning point. It starts increasing at -1, 0. The x value in that is -1. It stops increasing right here, and we're going to say that's around 0, 3, so the x value is 0. Now, that's not the only place that it is increasing, so we have to put the other one. There we go. So it begins increasing right here at 3, -4, so the x value is 3. And it never stops increasing. That's what that arrow represents. So it's going up, the x values are increasing forever. So that means they're going to be positive. Now we also put this u in between them. That is a union. That's saying these two places together are where this is increasing. So it's uniting the two intervals where the graph is increasing. So decreasing interval. Again, we're talking about the x values. So we can see the x value when it stops decreasing, and that's at -1. It starts decreasing based on this arrow, which is your negative infinity. Because it's going to the left, it's a negative infinity. And there's the second point, so we have to unite them using that unity symbol. And then we have, this is where it starts decreasing, is when your x value is 0, and it stops decreasing down here where your x value is 3. Now there's no flat areas on this line, so we have none on the constant intervals. There are no constant intervals. Now the absolute maximum. Absolute maximum is an ordered pair. So if we have these ends of the line that point towards infinity, that means there is no one ordered pair at the top of this graph. So we write none. There is not one highest point. Oh, sorry, I wrote that in the wrong place. I did maximum first. So none on the maximum. For the minimum, the absolute minimum, the lowest of low points is down here. So this is the lowest part of your graph. And remember, these are written as coordinates. So this is 3, -4. Now the relative minimum is another low turning point, but it's not the lowest one. So that would be right here at -1, 0. And your relative maximum, it's another turning point that's a high point, but not the highest point. I always say think of your maximums and minimums as peaks to mountains and the dip of a valley. So it always has to have that turning point. All right, domain. So the domain of your function is how far left and how far right. And again, this is referencing the x variable. So how far to the left does this graph go? On the left side, there's an arrow, which means it's going to go towards the negatives forever. And then how far to the right does it go? On the right side, there's another arrow, which means it's going towards the positives for infinity. So again, this answers the questions. How far left? And how far right when we're talking about interval notation. So the range talks about how low, because it's your y values. Your y-axis is up and down, so your range is referenced as your how far down and how far up. So the farthest down point is this 3, -4. Since range is your y values, we use the -4 here. And then how far up? Again, we've got the arrows pointing up, so it's going towards positive infinity. Now, because there is a point on 3, -4, that -4 is a value on this line, and it's a value where it stops. So we use a hard bracket. Parentheses, we use a parentheses with infinity because you can never reach infinity. You can't stop at infinity, so we use that parentheses. So the x-intercepts. I'm going to erase all that I have going on over here. So your x-intercepts are the points where the line crosses the x-axis. So when we look at this, we're looking at the x-axis. So it crosses at -1, 0, and we want these always written as an ordered pair. It crosses at 2, 0, and it crosses again at 4, 0. Again, your x-intercept has a y value of 0 every time. So look at all your ordered pairs where the y value is 0. So the y-intercept is talking about where it crosses the y-axis, which is this straight up and down one. And there's only one place where it crosses, and that's at 0, 3. The x value is 0. All right, the last thing on here is end behavior. So as x approaches negative infinity, that's how we read that. So the x-axis, where the negative numbers are, is to the left. So this other one where it says x approaches positive infinity, on the x-axis, the positive numbers are on the right. So remember, x is always left and right. So this y values are either up or down. So when you look at your graph, on the left side of your graph, on this left end, it's pointing up. And up is where all the positive numbers are, so it's going to be positive infinity. And then on the right side, we have another arrow up. So I'm going to write up, and then this is also positive infinity. So at both ends of your line, they're both pointing up, which means they approach positive infinity. All right, moving on to the next one. So we're starting off with interval of increase, decrease, and constant. So I'm going to get my highlighter at the very beginning. So you always start at the far left side of your graph. I see that it's going up. And then it goes down. And then it goes up again. Don't forget your arrows. They are important. So our increasing interval, it stops increasing. Remember, these are your x variables. So it stops increasing at -2. So I'm going to start my ordered pair with the second half. It stops at -2. And it starts with this arrow pointing to the left, which is where the negative infinity is. And we have another section that's labeled in green, so I'm going to put my union there. And then we see that it starts increasing again here. The x value is 4. And it never stops increasing. So it's going to the positive values for infinity. So then our decreasing interval. Still talking about the x values. So it starts decreasing right here, and it stops decreasing right here. So the x value from our start to our stop is -2 to 4. So that is your interval, -2, 4. Again, there's no sections that have, there's no flat sections in this where it's not going up or down. So the constant interval is none. All right, the absolute minimum. Because we have an arrow pointing down, that means there is not an absolute minimum. There's also an arrow pointing up, so there's not an absolute maximum. There's not one specific point where this stops going up. So the relative minimum, it's another low turning point, but it's not the lowest point. And this is our low turning point at 4, -6. Relative maximum is another turning point on this graph. That's the only other turning point, and it's a peak of a mountain, not the dip of a valley. So it is -2, -3. Moving on to domain. Domain is your x value, so how far to the left does this go? Infinity. And the left is negative values, so it's negative infinity. How far to the right? There's another arrow, so it goes to positive infinity. The range is your y values, so how low does it go? We've got an arrow pointing down. Down is where the negative numbers are, so it's going down to negative infinity. And then we have an arrow pointing up for how high, so it's positive infinity. So your x-intercepts are where your line crosses the x-axis. The x-axis is this one. I'm going to mark it over here. So it crosses your x-axis at 6, 0. Your y-axis, your y-intercept. This is your y-axis, so it crosses right here at 0, -4. Last thing on here is end behavior. So I like to go ahead and write left and right in here because it makes things a little bit quicker and easier, in my opinion. So as x approaches negative infinity, again, x-axis negative is left, and x-axis positive is right. So as we look at the far left side of our graph, the end of the line on the left side, it's pointing down. And down is where all the negative numbers are, and it's got an arrow pointing down, so it goes towards the negatives forever. And then on the right side of your graph, we have another arrow, but this one is pointing up. And up is where all the positive numbers are, so the arrow lets us know it's going up forever, so positive infinity. On our next page, going over this, we have this. So this is another of the same type thing, except we have an end point and we have a flat section. So that's how this one's going to differ. So interval of increase and decrease. Far left side of my graph, I notice it's going down, and it stops going down right there. And then it starts going up, and then last but not least, it's flat, and we have an arrow. So constant, decrease, increase. So again, for all three of these, we are referencing the x values. So I'm going to go ahead and put that off to the side. So we have, these are the x values. So if I look at the x values when it starts increasing and when it stops increasing, it starts increasing right here, it stops increasing right here. The x values in those two ordered pairs are 0 and 3. So our interval of decrease, it starts right here and it stops down here at the 0, -4. So the x values are -5, 0. And then that constant section. So here's the beginning of my blue section. It starts at 3, and then we have this arrow that lets me know it goes towards those positive values forever. So an absolute minimum. We do have an absolute minimum on this one. So your absolute minimum is the lowest point on the graph. So the lowest point we have is this one right here, and it is 0, -4. So the absolute maximum. So this one, there's our highest point, and it's not quite a point on this graph because it's got that open dot, but around that area is your highest value. So a relative minimum, there's no other dips, no other valleys in this entire thing, so this one is none. The relative maximum. So we do have another changing point that is like the tip of a plateau. So that is your relative maximum, is 3, 5. So it's like you climbed the mountain and you ended up at a mountain with a flat top. Okay, domain, those x values. So how far to the left does this go? It goes to right here. So we have -5 on the left side. Now, because it's an open dot, it doesn't actually touch -5, it just gets close to it, so we use a parentheses. On the right side, we have an arrow, which lets us know it's going towards the positive numbers for infinity. Again, you don't touch infinity, so it's a parentheses. So the range. Range is your y values. So it goes down to -4. Remember, it's your y values, so you look at the y part of your ordered pair. So it goes down to -4. -4 is a point on this line, so we use a hard bracket. And then it goes up to this highest point, which is at 7, but again, it has an open dot, so we use a parenthesis. X-intercepts are where your line crosses the x-axis. This is your x-axis, so it's at -20 and +20. And then your y-intercept crosses the y-axis, which is this one, so it's 0, -4. All right, end behavior. So if we look at our graph, it says as x approaches -infinity, our x values do not go to -infinity. So there's no end behavior on that side. On the right side, our x values do go to positive infinity, but they don't approach negative or positive infinity. As x approaches positive infinity, your y value is 5. So that is not end behavior. All right, last problem on here is domain and range. Now, this one is different from everything else on this graph because it's a bunch of dots on a graph instead of a solid line. This is discrete. Discrete is dots. Continuous is connected. So if your points that make up the function are connected, it's continuous. So this is dots, so it's discrete. Now, I like to write the domain and range simultaneous because you should be able to plot every relation based on the domain and range for a discrete function. So what I like to do is I like to make sure I put them in order. So I'm going to go ahead and put my brackets. I know there's a point here, a point here, a point here, a point here, and this just helps me make sure that I'm putting them in the correct order. So I see the farthest left point is -5, -1. Domain is your x, range is your y. So -5 is my x, -1 was the y. So on the next order pair, we have -3, 0. -3 is the x, 0 is the y. Next one is -2, 4. -2 is the x, 4 is the y. Then we have 0, -4, 0, -4, 1, 2, 3, and we have a -1 and a 5 with that 3. I like to put the -1 first because it's the smaller value, and then we put our 3, 5 next. And the last ordered pair is 7 as the x value, 0 as the y value, and we are finished.